Now that our wishbone is complete, we can start to interact with the results in various ways. And one of the simplest ways to get that process started is to open up a figure. And we're just going to start using normal plot types to visualize and interact with the data. So to get started, we'll just bring up any plot type. And what we want to do is first acknowledge the fact that Wishbone puts out results somewhat similarly as a dimension reduction algorithm. So if we actually look at these features or markers that we have available to us, we'll see that Wishbone has put in two new ones. One is traj for trajectory, and one is for the branch association that Wishbone is finding. And WB stands for Wishbone. So we can actually set these as our axes and start to learn about our results. So we'll do that now. And to better visualize this, I'll make it bigger. What we see in the trajectory column is the actual pseudo-time ordering that Wishbone has assigned to our cells. So each dot is a cell, as usual. And on the far left is our starting point, and it's ordered them according to what it thinks is the developmental trajectory. Also on the y-axis, we can see the branch column. And where the value of 1 is right here, and this is the trunk, the main trunk of development. And when you see the branch point, you'll start to see cells either in branch with a number of 2 or 3. These are the two branches that Wishbone has found. So we have the trunk and then a single branch point that results in one of 2 branches. A good thing to check out here is that this association actually makes sense in terms of our expectations. So we're always looking for a main branch, rather a main trunk, and then we're looking for a branch point, and then we want to see the cells have kind of cleanly gone into these branch points. Sometimes if Wishbone hasn't worked quite correctly, and it's not always clear why, given the complexity, you might see a pattern that doesn't look like this. So you might see the branches appear and the trunk come back into place. And we generally consider that to be kind of shrug and say, not clear why Wishbone isn't working quite correctly. So keep that in mind. Feel free to engage with us if you see that. What we can start doing from here is a few tricks with these plots to start learning about our data. So what I'll do with this one is actually convert it into a colored continuous plot. And what I'll also do is disconnect the X and Y resolution, make X a little bit wider, make Y a little bit shorter. And what this does is just gives us a quick indication of, for any given marker, and given the main trajectory and the branches, what are the cells doing in these cases? And so, if the pattern is obvious enough, we can start to see, for example, CD5 is low here, and then it becomes higher in the trunk and the other branches. We can also permute this as usual, maybe choose other markers of interest to us, and create plots for them as well. And then we can start to see patterns emerge potentially, like CD4 is clearly in branch number 1 is very high, but low in branch 2, whereas it's the opposite for CD8. And this can be useful. Another thing that we can do in a similar vein is, I'll just clear these out. We can use our UMAP to learn more about what was happening. And you don't have to use UMAP. Obviously, other dimension reduction would work, but again, UMAP is kind of nice with trajectory relationships on its own. And what we can do here is actually color this UMAP by our trajectory. And then we'll just duplicate it, or we could permute it, obviously. And we'll color it by the branch as well. And so now if we select these, just make them a little bit bigger, we can see that the UMAP actually does kind of align nicely with the trajectory. So we're looking at the trajectory column here. And blue is early on in the trajectory, so we can see that our start cell is clearly right here. And as the trajectory increases over time, of course, you'll see the value going up. And so we can see that Wishbone is finding this trajectory through this part of the data. And then we get here, and we're kind of at the terminus of the trajectory. And looking at our branch is actually what helps us understand what's happening here. This is clearly the branch point. So the trajectory is ending here. In a branch point, we have branch 1 and 2. We can further understand what other markers are at play here in the traditional manner. So we can bring up, any other marker that we care about and permute those and bring those into play and look at them on the UMAP. We jump back out into our workflow to demonstrate a continuation of the principles that we were just looking at. So what I'm going to do is actually throw some gates on those distributions. So I'll bring up my trajectory and branch, and I reverse them. And what I'm going to do right now is actually just grab these with gates really quick. So I'm going to make the trunk. I'm going to make branch 1 and branch 2. And now what I've done is simply to apply these gates to make sure that I'm filtering out these data points. And now what I'll do is open up a figure again. And I want to make a plot, and just pretty much anything will do, like solid works fine. And I want to set the filter first as my trunk. And then I want to set the x-axis as the trajectory. And now I want to permute this a couple times. I'm going to choose filter, and I'm going to permute by branch 1 and branch 2. And so now what I have in total, if I select this row, and I'll turn filters on, filter name on just to make it clear, is I'm looking at just the trunk of the trajectory, just branch 1 and just branch 2, but I'm looking at the trajectory as the x-axis the whole time. And so basically what this is showing me, and to make this a little easier, I'll make these a tad wider, is for the trunk and the 2 branches, I'm now looking at any given marker and I'm seeing what its pattern is at any given time. So for CD4, for example, I can see that in the trunk, it's pretty low, and then it gets higher before the branch point, and then is high in branch 1, and branch 2, it's low. And so, we could also turn these into any other plot type, or for example, permute them along other y-axis in this case, which would be other markers. So maybe CD44 and CD8 or anything else. Create new rows. Now for any marker, we're seeing the pattern that it expresses in different parts.